Hi, welcome. This is a lesson on how to solve quadratic systems algebraically. So just to recap though, real quick, we got a couple examples on what does it mean to solve a system of equations. If you have an equation, every point along along the line is a solution to that equation. So this point, let's say right here, which appears to be 3, 4, is a solution for this red equation here. And so if you plug in the value of 3 for x, and you were to square it, and let's see, 3 squared is 9, and 9 minus 5 is 4. So you get the corresponding y value. And so that 3, 4 is a solution, as is every single point along that line that is a solution for that graph. So what you're looking for in a solution of systems is you're looking for the point or points that they have in common, because this point right here, for example, is a solution to both equations because it's on both lines. And this point right here is a solution to both equations. And you can solve things graphically, but sometimes it's hard to see exactly where that point is. So this is 2, it's in between 2 and 3, and the y coordinate appears to be 0, but it's hard to tell exactly. So what we're going to do is how to solve these systems of equations graphically. Likewise, if you're over here, you might have, this is if you had two quadratics, two parabolas, right? You might also have a situation where you have a parabola that goes up like this, so one like that and one like this, and they may never intersect, so they would have no solution for that system because they don't have any points in common. Likewise, you have a linear equation and a quadratic, and so you could have a situation where you have a line like this that does not intersect the parabola at all, and so that, if you had one parabola like this and one line like this, those don't intersect, and so they would have no solution. But those are some examples. But we're looking at when you have some solutions. This is where you might see this point there, and there's a point there, and those would be the solutions. And again, we're going to see some of those examples in the following examples here, how to do that. Let's look first. So when we're solving algebraically, we have two ways of doing this. One is substitution, and the other one is elimination. Those are basically our two methods. And we'll practice at least one of both of those. In this case, both of these are equal to y. Y equals this, and y equals that. So it goes back to this property that says if A equals B and B equals C, then A equals C. So if you've got something equal to B and you got something and B equal to C, then your A is equal to your C. These two are equal to each other. And that's what we have here, is we have y is equal to this and y is equal to that. And so we can take both of these two equations and set them equal to each other. Let's look at what that looks like. So we've got 2x squared minus 8x plus 7 is equal to negative x squared plus 4x minus 2. And now we want to solve this equation. So we want to put it all like in standard form. I'm going to add x squared to both sides. I'm going to subtract 4x. I'm getting everything off of this right-hand side. Subtract 4x, subtract 4x. I'm going to add 2 and add 2. So these cancel and these cancel and these cancel, and I'm left with, on the right-hand side, 0. That's what we need to have it in standard form. Then we get 3x squared minus 12x plus 9 equals 0. And then I want to try to solve this I notice that each of these has a 3, so I'm going to first factor out a 3, and that gives me x squared minus 4x plus 3 equals 0. And then I'm just going to worry about solving what's inside here. What makes that equal to 0? So my a is 1 and my c is 3, so ac is 3, and b is negative 4. So since this is positive, they're going to be both of the same sign. I'm going to say negative 1 times negative 3. And when I add negative 1 plus negative 3, I get negative 4. So those are the numbers we're looking for to factor this. Put it in the box. X squared plus 3 minus 1x and minus 3x. And these have x in common, and these have x in common. These have 3, and this has 1. And then I look and I say, well, I think that's negative, and that's negative. And so my factors are 3 times x minus 1 times x minus 3, and all of this is equal to 0. So of these 3 factors, only 2 of them can be equal to 0 because they have a variable. 3 does not have a variable, so we'll just ignore that, and we say x minus 1 equals 0, or x minus 3 equals 0. And adding 1 to both sides here makes x equal to 1, and adding 3 to both sides here makes x equal to 3. Now, we are halfway there. We then have to go back to either one of these equations and put in x equal to 1 and x equal to 3 to find the corresponding y values. So let's put it in the top number here. Let's say just because that's what I chose. Y equals, and I'm going to do x equals 1 first. X equals 1. Y equals 2 times 1 squared minus 8 times 1 plus 7. And that gives me 2 minus 8 plus 7. And that's minus 6 plus 7. And that's 1. So my first solution is at the point 1, 1. And look at the other one, say x equals 3, and I put in y equals 2 times 3 squared minus 8 times 3 plus 7. And I'm just substituting in this x equals 3 and this x equals 1 into one of the two equations. And it doesn't matter which one because it has to be a solution for both. But I chose to put it in the top. You might choose the bottom, and that's fine. So 3 squared is 9 times 2 is, let's see, switch back here. 9 times 2, 18. Minus 8 times 3 is 24 plus 7. And 18 minus 24 would be negative 6 plus 7. Negative 6 plus 7 is 1. And so the second solution is at 3, 1. And so our two solutions are 1, 1 and 3, 1. All right. Excuse me. Let's look at example 2. This time we have a quadratic equation and a linear equation. So it's like this one up here. Once again, though, we've got y equals to on both equations. You got your y alone. When you've got substitution, you want to solve for one variable. And if you're already given the equation in terms of one variable, then substitution is a good way to go. So here I write x squared minus 5x plus 7 equals 2x plus 1. And excuse me, I'm going to move everything from the right over. Subtract 2x and subtract 2x, minus 1 and minus 1. So 2x minus 2x is 0, and 1 minus 1 is 0. So the right-hand side now is 0. And on the left, I've got x squared minus 7x plus 6. Then go over here and say, okay, AC equals 6 and B equals negative 7. That'd be negative 1 times negative 6 would be negative 7 when you add them. So when I put it in the box, I get x squared plus 6, and then minus 1x and minus 6x. And there's an x and an x and a minus 1 and a minus 6. And so the factors are x minus 1 times x minus 6. And then I say x minus 1 equals 0, or x minus 6 equals 0. Adding 1 gives us x equals 1, and adding 6 gives us x equals 6. Now we need to plug them into one or the other. This time I'm going to choose the bottom one just because I think it's easier to substitute into that linear equation. So when x equals 1, I've got y is equal to 2 times 1 plus 1. 2 times 1 is 2. 2 plus 1 is 3. And so one of the solutions is 1, 3. And then when x equals 6, I've got y is equal to 2 times 6 plus 1. And 2 times 6 is 12, plus 1 is 13, so y is 13. So the other solution is 6, 13. And that's what that looks like. Let's go to the next page. Now, this one is kind of a good candidate for seeing about elimination. I look at 4x and negative 2x, and I say if I were to just multiply this equation by 2, then this becomes negative 4x, and that would eliminate the positive 4x. So I'm going to do that. I'm going to take all of this equation and multiply it by 2. And I'll then write all of this out here to the side. I've got 4x plus 8y. I'm not doing anything with the top one other than just copying it down, equals negative 20. And when I multiply this other equation by 2, I get negative 4x minus 16y equals 28. And then I add the equation to the other equation. 4x minus 4x is 0. Those just kind of eliminate each other. 8y minus 16y would be negative 8y. And negative 20 plus 28 would be a positive 8. And then I would divide through by negative 8. Divide by negative 8, divide by negative 8. Y then is equal to negative 1. Now, these were two linear equations. So when you have two linear equations, remember their graphs are aligned, so you might have something that looks something like that, and they're only going to intersect at one point. They can intersect at no points, in which case there would be no solution, but this is one where they do have a solution. So we know that y value. Then we just go back and put it into one of these equations. I'll choose the top one. 4x equals 8, no, equals, sorry, 4x plus 8 times y, and y is negative 1, equals negative 20. 4x minus 8 equals negative 20. Add 8. And then 4x equals negative 12. And then divide by 4. X then is equal to negative 3. And so in this case, the solution is negative 3, comma, negative 1. And there's just the one solution because, like I said, these are linear equations as straight lines. Example 4.
Happy end of the quarter, teachers. If you'd like to come down and hang out to the conference room, we have a refreshment for you to celebrate the end of the quarter. Again, teachers.
I'm going to take that second equation. I'm going to take the second. I'm going to take the second equation and solve for y. So because it's negative, I'm going to go ahead and add y, and I'll add y over here. Let me write it over here, add y. And then I'm going to move the 1 back over this side, so I'm going to subtract 1. So that cancels the y here. This cancels the 1 here. And what I'm left with is y on the right is equal to 2x minus 1. And I can't combine them as they're not like terms. So I just leave it as 2x minus 1. Now that I've taken we'll call this one equation number 2, and this one equation number 1, I have solved for equation number 2. I'm going to substitute in for equation number 1. So I've got x squared minus 3x minus, and then I'm going to put in y. So let me highlight this here. That's y. Well, here's y on the second equation, and y is equal to 2x minus 1. So I'm going to put this in here, but I'm actually going to put this in here because it's equal to y. So I got x squared minus 3x. I need to put it in parentheses. Minus 2x minus 1, close parentheses, equals 7. So I just put that. That's minus y. Well, there's minus y is 2x minus 1, so just put that in there. But you do need to put it in parentheses, otherwise your signs aren't going to come out right. Now I need to just solve this. X squared minus 3x minus 2x. I'm distributing the negative. Minus 2x and plus 1 equals 7. I'm going to combine these two terms here, and I'm going to bring the 7 over. So I'm going to bring the 7 over here by subtracting 7 and subtracting 7. So all of this comes together here. I've got x squared minus 3x and minus 2x is minus 5x. And then plus 1 minus 7 is minus 6 is equal to 0. Now, I go to A, C, and B here. Let's see. AC is negative 6. B is negative 5. So with a little search, I can find two numbers that multiply to AC and add to B. That would give me 1 and 6 and make this negative and this one positive. 1 times negative 6 is negative 6, and 1 plus negative 6 is negative 5. Because they have different signs, you subtract. Now I go to my box and I say x squared minus 6 plus 1x minus 6x. And here these have an x in common, and these have a negative 6 in common, and this has a plus 1 in common. And so my factors are x plus 1 times x minus 6 equals 0. X plus 1 equals 0, or x minus 6 equals 0. Here I subtract 1. Here I add 6. And x then is equal to negative 1. Here, these cancel also, and x equals 6. And so I've got the x coordinates for the 2. I then can plug them in to get the corresponding y value. So because I already have this one solved for y, I'm going to use that to find the y values. So I say 2 times negative 1 minus 1. 2 times minus 1 is negative 2. Negative 2 minus 1 would be negative 3. And so one of the solutions is at negative 1 comma negative 3. Over here I've got 2 times 6 minus 1, and that's 12 minus 1 would be 11, and so the other solution is at 6 comma 11. And those are the two solutions for example number 4. All right, example 5. You've got 2x squared, and on the bottom when you have minus 2x squared, this is a great candidate for elimination because I don't even have to multiply either of them to get one of the variables eliminated. So 2x squared minus 2x squared, I'm just going to go ahead and add those together. 2x squared minus 2x squared, they basically cancel each other out. Minus 8x plus 8x, those also are opposites of each other and cancel each other out. So you're left with 0 on the left. And y plus 2y is 3y. And then minus 7 plus 4 is minus 3. If I add 3 to both sides of that new equation, I get 3y is equal to 3. And if I then divide by 3, I get that y equals 1. Now, I have one value of y. I'm going to go in here and find the corresponding values of x. So I go to the top equation there, and I would write 2x squared, and it doesn't matter which one you choose, I just chose the top one. 2x squared minus 8x equals, and then instead of y, I'm writing 1 minus 7. And 1 minus 7 is negative 6. Let's write this in here. Negative 6, and I've got 2x squared minus 8x. Then I'm going to add 6 and add 6. That gives us 0 on the right. We now have an equation here. This is squared. We now have a quadratic equation we can solve to find values of x, for which the value of y is 1. So I divide through by 2. I'm factor out the 2, x squared minus 4x plus 3 equals 0. And so AC is 3 and B is negative 4. So my numbers are negative 1 and negative 3. And those add to negative 4. If I put this in a box, then I get x squared plus 3 minus 1x minus 3x. And what they have in common is a minus 1 here and a minus 3 here. And so my factors are 2 times x squared, x minus 1 times x minus 3, and that's equal to 0. And then I set each of those equal to 0. X minus 1 equals 0. And x minus 3 equals 0. And here this gives us x equals 1. And here this gives us x equals 3. Then I go to one of the equations. No, I don't need to go back to one of the equations because they both have the same y coordinate, which means that the solutions are 1, 1, pairing this x equals 1 with that y equals 1, and also 3, 1. All right. Finally, here we got example 6. I'm going to, we have a single y for both of these. So before I do anything, I'm actually going to kind of put them in a standard form. I'm going to solve them for y. Solving the first equation for y gives us y equals 4x squared minus 16x plus 22. Okay? The 4x squared was already on the right. Subtracted the 16x, and I added 22. Solving the second equation for y gives us y is equal to minus 4x squared plus 24x minus 26. So I just subtracted 4x squared from both sides. I added 24x to both sides, and I subtracted 26. And now I notice that the 4x squared and the minus 4x squared are opposites of each other, so I can just add them. Add the one equation to the other. So y plus y is 2y is equal to, and then these just cancel each other out. 24x equals, 24x and minus 16x, they add to give us a positive 8x. And now I'm looking at this, I think maybe that I chose a bad way to do this. They're both equal to y. So I'm gonna rewind and use substitution, setting the two equations equal to each other. So I've got 4x squared minus 16x plus 22 equals negative 4x squared plus 24x minus 26. And now I'm going to solve this equation and see what I get. So I'm going to add 4x squared to both sides to get rid of it on the right. I'm going to subtract 24x from both sides to get rid of it on the right. And I'm going to add 26 to both sides to get rid of it on the right, leaving on the right 0. Put this in standard form. So now I've got 4x plus 4x squared is 8x squared. And the minus 16x and minus 24x would be minus 40x. And 22 plus 26 would be 48. And I notice 8, 40, and 48 are all multiples of 8. So I'm going to factor out an 8. And that gives me x squared minus 5x plus 6 equals 0. Now, AC is 6, and B is negative 5. And so with a search through the numbers, you can see that negative 2 times negative 3, and negative times negative is positive. And when you add a negative 2 plus a negative 3, you get negative 5. So those are the numbers we're looking for. I then put it in the box. I get x squared plus 6 minus 2x and minus 3x. And that gives us x and minus 2 and minus 3, and the two factors then are x minus 2 times x minus 3 equals 0, and x then equals 2 from the first factor, and x equals 3 from the second factor. We need to find the corresponding values of y. So I'm going to go back up to the equation that I solved for y on one of these, and I'm going to put in 2. So y equals 4 times 2 squared minus 16 times 2 plus 22. And I'm going to evaluate. That's 4 times 4. Just write that as 16. And negative 16 times 2 would be negative 32 plus 22. 16 minus 32 would be negative 16 plus 22. And negative 16 plus 22 would be 6. So one of my solutions is the point 2, 6. And we've found the corresponding value for 2. Now we're going to go in and find x equals 3. So I'll just go over here and write here, let's say x equals 3. Y then equals 4 times 3 squared minus 16 times 3 plus 22. And that's 4 times 9. 4 times 9 is 36. Minus 16 times 3 would be 48 plus 22. And 36 minus 48 would be a negative, negative 12 plus 22. And negative 12 plus 22 would be 10. And so the other solution is at 3, 10. And those are the solutions that you're looking for here. All right, work hard, practice, study. You got this.